want to take a moment to compare and contrast descriptive studies, correlational studies, and experimental studies. For descriptive studies, we're focused on describing the world around us, and there are a whole bunch of different ways that this can be done. The first is through case studies, which is an in-depth look at one particularly interesting case. We also have naturalistic observation. And this is basically just going out into the real world and describing what you see. And then we also have surveys and interviews. Where we're asking people about their own experiences. In correlational studies, we want to see whether or not two things are related to each other. And so when we're looking at the relationship between two different items, there are a couple of things that we want to know about it. The first is that we want to characterize what type of relationship it is. So is it a positive relationship? Do two things vary together? Or is it a negative relationship? When one thing increases, does the other decrease? Another thing that we want to know is the strength of that relationship. Whether or not two things seem to be strongly correlated with each other or just weakly correlated with each other. And both descriptive studies as well as correlational studies tell us something really interesting about the world around us. Descriptive studies show us what the world actually is, and correlational studies allow us to dig a little bit more into that, to see if two things might be related to each other. However, while both of these types of studies can give us really important information, neither of them can say anything about causation. So no matter how related things seem to be in a correlational study, we cannot say for certainty whether one thing is causing the other thing or that second one is causing the first one. And it's actually even possible that there's a third variable creating the effect and we just don't know about it. If we actually want to look at cause and effect, we have to do experimental studies. And we can do this by manipulating one variable while holding all of the others constant. And this way, any differences that we see, we can attribute to our manipulation. And we know this because nothing else has changed in this study. So let's look at an example to see how each of these types of studies can be used. And maybe I start off with a single observation that sometimes people listen to music while studying. And the first thing that I would want to find out is how popular this behavior really is. How many people listen to music while studying? What kinds of music do people listen to while studying? Do people listen to music while studying certain subjects but not others? And I can even do a survey and ask the music listeners themselves why they like to listen to music while they're going over their notes. And in this case, I've learned a ton about the use of music in study behaviors. But I can't really say anything conclusive about it. I know that there's this interesting effect that we see in the real world, and I can describe it all I want, but I can't say anything about whether or not this is a good behavior or a bad behavior or anything like that. On the other hand, if I hadn't done this descriptive research, I probably wouldn't be able to go on to do any other kind of study because I wouldn't really know what I was looking at. I wouldn't have addressed all the really base initial questions. If I wanted to follow up that descriptive study with a correlational study, maybe I would ask people to report on how often they listen to music while studying and also their overall GPA. So let me take a moment to graph that. So here I'll put GPA on the y-axis, and here we have a 4.0 at the top, and I guess a very unfortunate 0.0 on the bottom. And then on the x-axis, I'd have how often people listen to music while studying. And maybe I'll think about that in terms of how often they do it per week. So maybe here's once a week and twice a week and 5 or 6 or 7 times a week. And with this data and with this graph, I would be able to see if there was a relationship between GPA and hours of musical study time. So maybe I'd see a positive correlation. Maybe I would see something like this. And here let's look at GPA. So here we have people who have low GPAs tending to not listen to a lot of music. And in this case, wow, people who have 4.0s, people who have 3.9s, people who have really high GPAs, they tend to listen to music while studying a lot. And so that would be a positive correlation. But maybe I'd see something else. Maybe we would see something that looks like this. Now it seems that people who have really incredibly low GPAs, wow, they listen to a lot of music while studying. And the people who have really high GPAs, they don't seem to listen to any music at all. And so here we would say that there's a negative correlation between GPA and number of hours that someone's listening to music while studying. And of course, as always, it's possible that we get no relationship at all. So maybe our data points are actually all over the place. And there's absolutely no relationship between GPA and how many hours someone listens to music while they study. But as interesting as this is, and as much as it can tell us, it can't say anything about causation. We can't say that one of these things is causing the other thing. So, for example, we might want to theorize, in the case of this negative correlation, that maybe people who are listening to music while studying, maybe they're actually paying a lot of attention to that music and not really a lot of attention to why they're studying, and that's why they have such a low GPA. And then here, the people who have 4.0s, they don't listen to any music, so maybe they're removing distractions from their environment. And it's easy to see directionality within a graph like this. It's easy for us to say that somehow listening to music is what's affecting the GPA scores, or what's driving the GPA scores, but maybe it's exactly the opposite. Maybe people who are naturally good students don't really like to listen to music, and maybe people who are poor students, they don't want to bother, so they like to listen to music while studying because they're not really going to focus on it anyway. Or maybe there's some kind of third variable that we don't know about that's driving all of this. Wow, I don't even know what that would be, and that's kind of the point. If there was a third variable that was somehow driving any of these correlations, we may not even know about it, and that's why we can't draw any conclusions about causations from correlational studies. Now let's look at how this could be studied with an experimental study. So maybe here I'll operationally define GPA, or doing well on tests, as doing well on a memory task that I have. And then when we talk about music, we'll talk about whether or not music is being played to the students while they're studying for this memory task. Let's give ourselves 3 conditions. So we'll have a music condition, where students will be listening to music while studying for a memory task, and then they'll have a break, and then they'll be tested on their memorization of that previous material. We'll have a no music group, which will be the same thing, except that they won't be listening to any music. And then let's add another group. Let's just add maybe a white noise group. Or maybe a background noise group. Because it's entirely possible that listening to anything, not necessarily music, might be influencing how well people do on a memory task. And if that's the case, then I want to know it. Alright, so I have these 3 conditions, and I have randomly distributed the Psych 101 undergrads into these 3 conditions. They come into my lab, I have them sign consent forms, and then I sit them down and have them read over a list of maybe 50 words. And maybe they'll have, 10 minutes to do so. And after that 10 minutes, I'll have them do some kind of distractor task, maybe counting backwards from 243 by 7, something to basically just sort of get the different words out of their head to sort of keep them from rehearsing them. And then after they've counted back from 7 for a certain period of time, then I'll ask them to recall all of the words that they can that they think were on that original list. So it'll be a free recall task. So if I look at my results, what might I see? Maybe on the y-axis, I'll just have number of words recalled. And then on the x-axis, I'll have my different conditions. So I'll have my music group, which I'll symbolize with this M. I'll have my no music group, which is NM. And then I'll have my background noise group. So that'll be background noise. And what do I see? Well, maybe the people who listen to music were able to remember, 20 words. And the people who had no music, maybe they were able to recall 30 words. And maybe the people with background noise, maybe they were somewhere in between. Maybe they recalled 25 words. And again, I'm just making this up, so please do not draw any conclusions about whether or not you should listen to music while studying from this. But in this make-believe graph, or this make-believe data that I have, we see that the people in the no music condition recalled more words in the music condition or the background noise condition. And these results also seem to indicate that listening to any kind of noise while studying might be pretty distracting. But that music might be even more distracting than sort of, background noise you might find in a coffee shop. But of course, this isn't the end. There are many directions you can go from here. So let's say that for this study, I used classical music. Well, maybe I could redo the study using more modern music. Or maybe I want to look at whether or not the volume of the music has any influence on the number of words recalled. Or maybe I want to look at whether or not the music having words or not having words changes this effect at all. So here we've taken this idea of listening to music while studying, and we've talked about how we could look at it using descriptive studies, correlational studies, and experimental studies. And as you can see, the kinds of things that you can do and the conclusions that you can draw are different for each of these things. But they're all really important in their own right. They all have a role to play.